Properties can be made static when we don't want to create instance to call the property. Private static int count. Public static int count. Get equals count. Set equals count equals value. A property may be marked as a virtual property by using the virtual keyword. This enables derived classes to override the property behavior by using the override keyword. Properties allow the following modifiers. Static modifier static. Access modifiers public, internal, private, protected, protected internal, private protected. Inheritance modifiers new virtual abstract override sealed. Unmanaged code modifiers unsafe extern. Class and structure. A class or struct declaration is like a blueprint that is used to create instances or objects at runtime. If you define a class or struct called person, person is the name of the type. If you declare and initialize a variable p of type person, p is said to be an object or instance of person. Multiple instances of the same person type can be created, and each instance can have different values in its properties and fields. In general, classes are used to model more complex behavior, or data that is intended to be modified after a class object is created. Structs are best suited for small data structures that contain primarily data that is not intended to be modified after the struct is created. Client code. Some methods and properties are meant to be called or accessed from code outside your class or structure known as client code. Access modifier. All types, class, structure, and type members, fields and methods have an accessibility level. The accessibility level controls whether they can be used from other code in your assembly or other assemblies. Point 1. Public. The type or member can be accessed by any other code in the same assembly or another assembly that references it. 2. Private. The type or member can be accessed only by code in the same class or struct. Point 3. Protected. The type or member can be accessed only by code in the same class or in a class that is derived from that class, i.e. without creating object of the base class. Point 4. Internal. The type or member can be accessed by any code in the same assembly, but not from another assembly. Point 5. Protected. Internal. The type or member can be accessed by any code in the assembly in which it's declared, or from within a derived class in another assembly. For the first part of the statement you can access a protected internal field myValue declared in first namespace in the entire assembly by creating object of that class. Namespace first, public class base class. Protected internal int myValue equals 0. Class test access. Void access. var base object equals new base class. Base object myValue equals 5. The second part it can be accessed in another assembly, say namespace second, via derived class. Namespace second, class derived class, base class. Static void main. var base object equals new base class. var derived object equals new derived class. Base derived object myValue equals 10 / works because this class derives from base class. 6. Private protected. The type or member can be accessed only within its declaring assembly by code in the same class or in a type that is derived from that class. I.e. Private accessible in that class and protected accessible in derived class without using an object. Variables declared in a method are private, and we cannot write private int x, as variables in a method or namespace have only one modifier. OOPs, object-oriented programming. OOPs is implemented using abstraction, encapsulation, inheritance, polymorphism. It is a programming model where programs are organized around objects and data rather than actions and logic. OOP allows decomposition of a problem into a number of entities called objects, and then builds data and functions around these objects. Inheritance, it enables you to create new classes that reuse, extend, and modify the behavior defined in other classes. The class whose members are inherited is called the base class, and the class that inherits those members is called the derived class. A derived class can have only one direct base class. However, inheritance is transitive. If class C is derived from class B, and class B is derived from class A, class C inherits the members declared in class B, and class A structs doesn't support inheritance conceptually. A derived class is a specialization of the base class. For example, if you have a base class animal, you might have one derived class that is named mammal, and another derived class that is named reptile. A mammal is an animal, and a reptile is an animal, but each derived class represents different specializations of the base class. Derived class implicitly gains all the members of the base class, based on the access modifiers used, except for the constructors and finalizers. Static constructors gets invoked only once, even if that class is instantiated multiple times.